In our last session, we talked about securing DNS data using DNSSEC. We want to look at two more options of securing DNS data. One is called DNS socket pooling, and the other is called cache locking. We want to begin by talking about the DNS socket pooling. With DNS socket pooling, we are using what we call source port randomization when issuing queries. And this provides enhanced security against cache poisoning attacks. Now we have a socket pool within DNS. This socket pool is enabled with default settings on computers. But we can also customize the socket pool setting. Now let's take a look at what happens when a query is made to a DNS server. A query is sent to the DNS server, and that server sends the query to the authoritative DNS server. That is the server that has the record that you're looking for. The authoritative DNS server will reply through a port. And this reply comes back through a source port. And it is at this source port that your data becomes vulnerable to an attacker because you're using the same source port all the time. So it makes it easy for the attacker to learn your route and attack that data. With source port randomization, the DNS server will randomly pick a source port from a pool of available sockets that it opens when the service starts. What does socket pooling do? Well, instead of using a predictable source port when issuing queries, the DNS server uses a random port number selected from a pool. And this pool is known as the socket pool. So the socket pool makes cache poisoning attacks more difficult because the attacker has to correctly guess the source port of a DNS query in addition to a random transaction ID to successfully execute the attack. Let us take a look at what can occur without port randomization. We have the DNS client here. Let's say the DNS client makes a request. DNS client wants to go to barbados.com. So the request is sent to the DNS server, which is a recursive server, meaning that that server does not have the address barbados.com in its database. So it's going to look for the server that has that address. So the DNS server will send that query to the authoritative DNS server, which is the server that will have information on barbados.com. The authoritative DNS server is going to reply back to the recursive DNS server, but it is going to do so using a particular port. So you have the same route all the time. So here in the top right corner, you have the brute force attacker. So this attacker is waiting and looking to find out that the port that this data is being transformed on. Right here, when the data is sent back to the recursive DNS server, your data is susceptible because the brute force attacker will easily learn the port that you're using. So what happens if your data is attacked? The incorrect response will be sent back to your client machine. meaning that you're not going to get Barbados.com. You're going to be redirected to a malicious site, and your account information then can be captured. With port randomization, you have a number of sockets. And so it is difficult then for the brute force attacker to pick out the route because there's so many different ports available with port randomization. Now, as I said before, the feature is enabled by default in Windows Server 2012. The DNS socket pool uses several source ports for issuing queries. So the query is not issued simply using one source port. Once that feature is available, the feature is turned on, which it is by default. You will have a query being issued on many different source ports. You can configure the number of source ports. You can increase the number. The feature cannot be controlled using DNS management tool. You have to either use it at the prompt, write the DNS command, or you have to modify the registry. To find out the number of source ports, at the command line, you can type the command dnscmd/info /socket pool size, which will give you the default number within the socket pool size, and you can also modify that number using the config command, DNS command /config/socket pool size. Let's say you want it to increase the socket pool size to 9,000. You simply type 9,000 at the command line. Let's take a look at the command. Again, DNS command /info /socket pool size will actually give you the socket pool size. To increase that socket pool size, you can type DNS command /config /socket pool size, and you enter the new size that you want for the socket pool size. This is a feature available with Windows Server that allows the administrator to control whether or not information in the DNS cache can be overwritten. DNS administrators can set how long a record will remain safe in a cache. The configuration is based on a percent value. For example, if you set your cache lock-in value to 50%, then the cached records cannot be overwritten until half of the time to live has been reached. DNS cache lock-in is set to 100% by default. This means that the cache records never get overwritten. What does cache locking really do? When a recursive DNS server responds to a query, it will cache the results obtained so that it can respond quickly if it receives another query requesting that same information. The period of time the DNS server will keep information in its cache is determined by the time to live value for a resource record. Until that time to live period expires, information in the cache might be overwritten if updated information about that resource record is received. So if an attacker successfully overwrites the information in the cache, they might be able to redirect traffic on your network to a malicious site. Cache locking can be configured using a command line. At the command line, and you want to open that command line at an elevated command prompt, you will type the DNS command /config/cache locking %, and then you type the % that you want to have for your cache locking %, and then you restart the DNS server. Cache locking can also be configured at the registry level, where you will simply type regedit to access the registry, and you can see here the path that you want to go. H key local machine system current control set services DNS parameters, and here if the cache locking % registry key is not present, you can right click parameters, click new, and click the word, then type cache locking % for the name of the new registry key. And what you then want to do is to type the value from 0 to 100 for the lock-in %, and then click on OK. And you restart the registry. You close the registry and then restart DNS server service. So we can configure the cache locking either at the command prompt or at the registry level. So we looked at 2 ways that we can secure data, and one was cache locking and the other was socket pooling. This is the end of our session on DNS socket pooling and cache locking. I want to thank you for listening.